Hello wonderful person, this is Anton, and today we're going to be discussing one of the most unusual discoveries when it comes to the supernova out there, and actually a survivor of a supernova, and a survivor that the scientists really did not expect to find. An unusual star that was recently discovered in a galaxy relatively far away that seems to have changed so much that it now appears to be much brighter than it used to be when it was originally found. Something that has never been seen before, and something that was actually not even believed to be possible before. And so let's discuss this particular discovery and some of the previous discoveries in regards to the supernova in more detail. But let's start with this beautiful image released by the European Space Agency very recently, showing us these beautiful spiral galaxies whose pictures were taken in the last couple of decades. Now what makes these galaxies really special is the fact that all of them contain what's known as Cepheid variables, a specific type of a variable star that's often used to determine distances to various objects in space, and all of them also had at least one Type 1a supernova, an event during which a white dwarf explodes, producing a very specific type of a supernova that often contains extremely similar luminosity that's also used to determine distances. And so by using these galaxies, the scientists have actually been able to determine distances to different objects in space, and also work out some other mysteries about the universe, including the expansion of the universe itself. Interestingly enough, in one of these galaxies, the supernova was detected so early on that the scientists were able to even observe it in real time, measuring its brightness and measuring how all of this progressed over time. This was in this beautiful galaxy known as NGC 2525, located 70 million light years away from us. And so understanding the evolution of these Type 1a supernova is super important for our general understanding of things in the universe, and more specifically for measuring distances to various very far away objects, because that's really the only way we can do it right now. And a lot of other studies are even trying to focus on supernova a little bit closer to home, such as the supernova that occurred in the region not so far away from the solar system, like for example in the molecular cloud known as the Orion cloud. For example, not so long ago the scientists realized that at least one feature known as the Bernard's loop, the feature that's visible as a kind of an arc extending away from the Orion's belt, seems to have been essentially created by an ancient supernova. And as all of this gas moved away from the center, and as all of this created a kind of a pressure wave, it then also started to trigger formation of other stars along this arc, with all of this suggesting that supernova play a huge role in a lot of different things in the galactic evolution. But that's something that the scientists have known for a pretty long time. But there are obviously some things that the scientists did not know or still do not understand. For example, how exactly do certain supernova get triggered, and why some supernova don't seem to progress in the same way? Why is it that certain supernova, even though they're supposed to be extremely powerful and extremely bright, end up either destroying the star only partially, or sometimes not destroying anything at all? While in other cases, the entire star gets destroyed completely, leaving nothing behind. And so very recently, the scientists studying this other galaxy, the galaxy you see right here, known as NGC 1309, located approximately 120 million light years away from us, detected what seemed to be a Type 1a supernova. Once again, a supernova caused by a white dwarf reaching approximately 1.4 masses of the Sun and exploding, creating something similar to what you see right here. Or that's what they thought originally. Actually, the original supernova was detected back in 2012, and it's known as SN 2012Z. But it's only now, 10 years later, that they realized something was not adding up. In this case, the scientists wanted to see if they could actually find a progenitor star by looking at this galaxy and this region slightly prior, but also slightly after the explosion occurred. And since in this case, Hubble has taken many images of this galaxy in the past, the chance of discovering something in this galaxy was pretty high. And one of the ways that we're going to do this is by looking in this region before the explosion occurred, and also after the explosion occurred, because technically there should have been just empty space. And they were expecting to find either one of two things, either absolutely nothing because the star exploded, or maybe the star was still there, and in this case did not change much because it wasn't the star that exploded. In other words, maybe the star was not detected by Hubble to begin with. But what they discovered was completely unexpected. They discovered that approximately 4 years after the explosion, the remnant was way brighter than anything that existed in this area before. Suggesting that not only did the star survive, but it actually became brighter at the end, visible from 120 million light years away from us. and also suggesting that this wasn't just a typical Type 1a supernova, but more likely a more exotic Type 1ax supernova that instead of destroying the white dwarf completely, ends up producing what's known as a zombie star, essentially a kind of a white dwarf remnant, with the explosion itself being only partial, very likely only using about 5 to 30% of the total energy. And because approximately 30 of these supernovae have already been discovered in the last few decades, it means that we don't entirely understand the actual process of white dwarfs going supernova to begin with. And so using them as standard candles to measure distances is still a little bit tricky. In this case, the supernova could actually be caused by the accretion of helium on the surface of the white dwarf, with the helium then exploding as an extremely bright flash, but the rest of the star might still be there. But in many cases, these unusual partial explosions can also produce what's known as a hypervelocity star. Basically a remnant of a supernova moving across the galaxy extremely fast, at hundreds of kilometers per second. Now it's not really clear if it happened in this particular case, but it is quite possible. But one major question here is, why exactly did it become brighter? How can it possibly become brighter after the explosion? Well, even though it's not super clear, there's at least one possible explanation. It's possible that when the explosion occurred, instead of completely blasting away everything, because the explosion was not super powerful, the blast ended up stirring things up, releasing a lot of the material that then started to settle back into a mass that was just a little bit less dense, turning into a kind of a less stable, less dense white dwarf, or possibly some other unusual exotic star that we're not very familiar with. And so by having a lot more volume of pretty much the same material, it now has a lot more brightness. But that's just one of the explanations. It's still unclear what's going on here, and it could be a completely new mystery to begin with. But it's pretty clear that this was an incomplete explosion, which means that this white dwarf, for some reason, failed. And that's kind of the question that scientists really want to answer. What makes certain white dwarfs fail, while others seem to complete the explosion, releasing all of the energy at once? And if the scientists are correct in their current assumption, years later, or possibly decades later, this white dwarf will very likely dim in brightness and will most likely assume a somewhat similar shape. It's going to be less massive and it's going to be a little bit bigger in size, but it's still going to be different from what it used to be, and so it's most likely going to decrease in brightness. And so by studying how this object evolves and what happens to it over time, it might actually become possible to answer some of these questions in regards to these unusual exotic explosions. But for now, that's I guess all we know. You can learn more about this explosion and all of the other relevant information from the paper in the description below. And once we have some answers from this galaxy, I'll make sure to follow this up in another video. Until then, thank you for watching, subscribe, maybe share this with someone who loves learning about space and sciences, and come back tomorrow to learn something else. Support this channel on Patreon by joining channel membership or by buying the wonderful person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.